Okay, so um, today we're going to start the new chapter. It's about logarithms, something called logarithms, right? Logarithms is one of those new concepts that you've probably never heard the word logarithm. You might, but you've probably never heard it, right? Last chapter we did exponents. Exponents you guys knew. Before we even did exponents in class, you guys knew what an exponent was. Logarithms is one of those things where it's a brand new topic, but it's kind of related to what you already know. Okay, it's kind of related to what you already know. So a logarithm is just a special way to ask a specific question. We use logarithms when we don't know what the missing part is, the exponent. Okay, so when we're missing the exponent, we use logarithms. Okay, so logarithms and exponents are very much related. In fact, they have the same parts. They have the same parts. So you can see right here where exponents. You guys have done that for a while, right? Exponents have bases. That's the big number. They have exponents. That's the little number. And then they have answers, right? 5 to the second power equals 25, right? You guys know that. A log uses those same parts, but asks a different question. What the log says is, okay, so 5, the base goes down at the bottom. What power is it going to take to make 5 into 25? The exponent now is the answer, 2. I need an exponent of 2. If I had an exponent of 2, 5 could turn into 25, right? So that's what logs do. Logs help us when we don't know what the exponent is. They're exponent finders. They help us find exponents. Okay? They still have the same parts. They have a base, they have an exponent, they have an answer. They're just in different spots. They're just in different spots. So like the one that's on the board, 5 to the second power equals 25, right? A log just says, okay, well, 5 goes down here. 5 is the base still, but it goes down there. The answer is 25. What exponent do I need to get there? To get from 5 to 25, what exponent do I need? 2. Okay. So exponents and logs are very much related. They're very, very, very much related. That's why we do logs after exponents, right? Because we've done a whole chapter on exponents. Now we're coming to logs. Okay. So one of the most important things to do is to switch back and forth. To switch from an exponent to a log or a log to an exponent. You always know which form it is because an exponent will always have an exponent. A log will always have the word log. In fact, on your calculator, there's a log button. You might not recognize it. You might not have seen it before, or the log right there. Okay, but it's on a calculator. Might not have used it before, but it's there. Okay. So to help you kind of move from one form to the other, there's what we call a loop trick. One of them's a loop, one of them's an L. Okay. So if you have a log, if you start with a log and you want to change it to an exponent, you can use this. Watch. Always start with the base. We always start with the base. So the base is here. What we're going to do is we're going to use a little loop that creates an E for exponent because I'm changing it to exponent form. Right? So it's kind of a cursive E. Well, which order did I draw that in? Well, first I started with the base, right? So base. And then I hit the X, That's the exponent. And then the last thing I hit was a. That's the answer, right? You can go that way, or you can go the other way. To go the other way, we're not going to use a loop. We're going to use more of a, we're going to create an L, right? So I use the E when I want to change to exponent form. I use the L, I'll show you the L right here. I use the L, kind of looks like a little foot, when I want to change to a log. L for log, right? Well, to do that, I started with the base. So it's going to be log with a base of b. And then I went to the a. And then the last thing that I touched was the x. Okay? It helps you kind of go from one form to the other. Because most of the time, you're going to have to go from one form to the other. Okay? All right. Okay, so let's do some problems now. Okay, so here, let me change this. Change the directions. The directions are wrong. It should say, instead of convert, change it to evaluate. Evaluate. And then instead of to, put using. That's what it should say. Evaluate the logarithm using below using exponential form. Okay. Well, let's look at 1a. 1a has a base, has an answer. It's missing an exponent, right? But that's the part we need to find. That's the part we need to find. So for each of these guys, we have to find the exponent. Okay? That's what they're looking for. They're looking for that missing piece. We have the base, that's 7. We have the answer, that's 49. We have to find the exponent. Okay? So we have a log. First thing we need to do is change it to exponent form. So we're going to use the E. Okay? So 7 to some power makes 49. 2 to some power makes 32. 4 to some power makes 1 over 64. So they're all changed to exponent form. Okay, so now what I have to do is find the missing part. So the first one, 7 to what power makes 49? What power am I going to take 7 to make 49? Squared. Mm-hmm. The answer is 2. Okay. 2 to what power makes 32? 2 times 2 times 2 times 2. How many times am I going to do that until I get 32? 5. Okay. And then the last one. The last one is a little, not tricky, but it's different. Because what power does 4 need to become a fraction? So first of all, to become a fraction, what's going to happen? What kind of power do we need? Negative. So it's going to be a negative power. That means it flips, right? That means 4 goes down to the bottom. Now, what power is 4 going to need to be 64? 3. So it'd be negative 3 power. Negative 3 power. Okay? Okay, so the next thing. Sometimes you'll have a log without a base. There won't be a base down there. Well, if there is no base, so if you have a log without a base, the base is actually 10. It's called the common log. So if there is no base, it's actually 10. Base is 10. Any other base, they'll write it in. But if they don't have a base, like 2a doesn't have a base written down. If it doesn't have a base, it's going to be 10. Okay? So this is 10, that's 10, and that's 10. So we have to figure out what these are equal to. That's what evaluate means. Evaluate means what are they equal to? Okay? Well, they're logs, so we're going to change them to exponents. Use the e. Okay. So it's 10 to what power makes 100? 10 to what power makes 1 over 100? 10 to what power makes positive 1? Okay. So 10 to what power makes 100? 2 squared, right? 10 squared is 100. Okay. 10 to what power makes 1 over 100? Negative 2. And 10 to what power makes 1 whole? 0. Yep. 0. Anything to the 0 power is going to give you a 1 whole. Okay, so log of 1 is always going to be 0. Okay. All right. Now the missing part kind of changes spots. It's in different spots every time. We just got to figure out what the missing part is. Okay, so the first thing we're going to do is we're going to change it to an exponent. So I need the e. If I'm going to change it to an exponent, I need the e. If I'm going to change it to a log, I need the L. Okay. So 7 to the x power equals 343. X to the second power equals 36. 7 to the third power equals x. Now I got to figure out what's the missing part. Okay. 7 to what power makes 343? Let's see. 7 squared is 49. Let's try 7 to the third power. Yep, 343. So the missing part is 3. Okay. X squared equals 36. Well, do the opposite. Take the square root of both sides. The square root of 36 is 6. Okay, last one. Well, this one's 7 to the third power. I just did that one, 343. Okay. All right. Last section. Same thing, but now we have fractions. It's the same thing we've been doing. So first thing we're going to need to do is change them to an exponent. So the first one. 36 is the base. -1/2 is the power. Equals what? Okay. So we just did this chapter right here. How do I simplify that? What do I need to do? What does -1/2 power mean? It means two things. What are those two things I have to do? Well, what's the negative mean? What do I have to do first? What does a negative power mean to do? Move it down. So now I have 1/36 to the 1/2. Okay. So now what does 1/2 power mean to do? What is 1/2 power? What does the 1 mean? What does the 2 mean? Mm-hmm. 1 is the exponent, so 36, and it's the square root. Square root of 36. The square root of 36 is 6. Done. Okay. All right, next one. 729. So we have 729 to the -5/6 power. Again, negative power means move it to the bottom. Okay. So 5 is the root, or sorry, 5 is the power, 6 is the root. So in other words, I have 6 root 729 to the 5th power. Okay. I'm looking for groups of 6. Do I have enough 729s? No, I only have 5 of them. So I don't have enough 729s to take one out. But what I can do is break down 729 and see if it has any. When you break down 729, let's see. $81 times 9. 81 is 9 times 9. And 9, each of those 9s is a 3. And then it's got another 9. So 729 is 3 to the 6th power. 3 to the 6th power. Each 729 has 6 threes. How many threes do I have total then? if each one of these 729s represents 6 threes, I have 30, right? Yep, I have 30 threes. 3 to the 30th power. Okay, so if I have 30 threes, 3 times 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 30 of them, and I'm looking for groups of 6, how many groups of 6 do I have? 5, so 3 to the 5th. So I go to my calculator. 3 to the 5th power is 243. 1 over 243. And you're done. Okay. All right, so I want you to do letter C now. Do letter C. Same way. Example 4 is a mixture of what we did last chapter and this chapter. It's got the log part, but it's also got the roots. Okay, so it would be 512 to the 2/3 power. That means I have 2 512s, and I'm looking for groups of 3. Well, I don't have enough 512s because I only have 2 and I'm looking for groups of 3. But if I break down 512, I'm going to have a whole bunch of 2s. In fact, I have 9 2s. I will have 9 2s when I break down 512, right? How many 2s am I going to have total? 18, yeah. Because if I have 2 512s, each of them has 9. Each of them has 9. Okay, so I'm looking for groups of 3. If I have 18 2s, I'm going to have 6 groups of 3. 2 to the 6. And 2 to the 6 is 64. Okay. All right. Okay, so last thing we're going to do, then we'll be done. I want you to, in your notebooks, do these 3. Evaluate each. Means give me the answer. What is the answer going to be? What is the missing part? Okay, these 3 and then we're done. So when you use the loop, the missing part is going to be the exponent. Each of them has a missing part as the exponent. So 5A. 5 to what power makes 125? Well, 5 squared is 25. 5 to the 3rd power. So 3 is the answer. Okay. B, what is the missing part for B? 5, yeah. They have to be equal. So the missing part is 5. Letter C. Well, one of them has a square root and one of them doesn't. So what power do I give something to make a square root? 1/2. So that if it had 1/2 power, that would be square root. Then they'd be equal. Okay. So 5A is 3, 5B is 5, 5C is 1/2. And you are done. All right, tomorrow we'll do some more practice. So tape into your notebooks.